Shri Gurubhyo Namaha. In last session, we have discussed what are the different data types in Python. Today in this session, we are going to discuss what is mutable and immutable types and what are the three key terms which are associated with the objects. Mutable and immutable objects in Python. So these are considered as mutable objects. That is, we are categorizing the data types into two things. One is your immutable type, the other one is mutable types. Under your immutable types, we have numbers, strings, and tuples. In mutable types, we have list, dictionary, and sets. So what is a mutable object and what is an immutable object? A mutable object, that is, in object-oriented programming language, the mutable object is an object whose state or value can be modified after execution. That is, the behavior or the values of the object can be changed. In short, object value for which we can change the value is called as your mutable objects or mutable variables. So what are the data types that we have? List, dictionaries, and sets. These are called as mutable objects. What is an immutable object? In object-oriented programming, whose state or value cannot be modified after its creation, which we call it as an immutable object. So for which we cannot change the value of immutable object. Examples: integers, floating point numbers, booleans, strings, tuples are considered as immutable objects in nature. How a Python stores objects internally? Variables internals. Python is an object-oriented language. Python calls every entity who stores values and type of data as an object. Object is an entity that has its properties and behaviors. So each and every object has its properties and its own behaviors. All data values are referred as Python in objects. Whatever it may be, a data or a value, we call it as an object in Python. So every Python object has three key attributes associated with. One is the type of value, the value of an object, and ID of an object. So what is type of an object? It's a type of an object which determines the operations which can be performed on that particular object. Suppose it may be an integer type, or it may be a float type, or it may be a string, right? So based on the type of value, the object is being, the operations can be performed accordingly based on the type of value. Built-in function, that is type, returns the type of an object. Suppose if I am declaring A as 5, so type of A gives me class int. That is, it returns what type of value the object is being referencing. That is, what is A value, what type of value it is. The value of an object, it is the data item contained in the object. So what item is present in that, which we call it as value. For a literal, it is the value, is the literal itself. For a variable, the value is the data item that's currently referencing. So why we call it as currently referencing? It is not a storage containers. The variables are not storage containers. That's why we call the term as where it is being referenced. ID of an object. It is generally the memory location of an object. So to know which object is being referenced, where the object is present. We can use the function ID, which tells the ID of an object, which means that the memory location will be returned by the ID function. ID of a variable is same as ID of value, storing a value. It may be a variable that it is being referenced or the value that it is being referenced. Now, let us understand this with a small examples. So, here I'm going to declare it as a value of p equal to 5. So, I have used a variable, that is p variable is for referencing to the object 5. That is internally all the objects will be there. The variable is made to point to that particular object. Here, what is an object here? 5 is an object. Q equal to P, right? Now let us refer the type of P. What is the type of P? Which is nothing but class int. Same way, type of Q is also class int. That is, both P and Q are the variables which is pointing to the object 5. So that's why both are integer types. Suppose if we check with the ID of P. So we are getting the memory location of P. Same way, we have assigned P to the Q, that is, which we have given, or the same memory location is being pointed, or the object is being pointed by the variable Q. Right? So from this address, you can understand that it is not, the P and Q are not storage containers. Instead of that, these are the variables made to point to the object value. So internally, you will be having many objects. So suppose if I'm changing the value of Q as 7, ID of Q. So now it has been made to point to a different location. That is, I'm not changing the value in the same location. Instead of that, I'm making my Q variable to point to a different object, right? So if it is going to be a storage container, in the sense, in the same location, the value gets changed. It is not happening in the Python language. So an object will be referenced by the variable, right? So we have seen internally, it is a three key internal attributes that we have. The one is type, the other one is ID, and the third one is the value. So based on the value, the variables are made to point. That is, it may change the data type or type of the value, or it may have a different address, right? So based on that, the Python refers the objects internally. Thank you, children. To receive our online lessons, please press the subscribe button and you will receive the latest updates.